with a presentation that I think is very timely with everything that's happening at Prairie View A&M University. We are moving towards a system of building an ecosystem of moving our research from the laboratory or from the field to the marketplace. And Anil's presentation is very timely because more and more we are having people who develop innovations that could move to the marketplace. So I want to make sure that everyone knows that today's session is being recorded. It will be available on our YouTube channel, which is PVAMU Research. I ask that you subscribe to our YouTube channel so that you can be apprised whenever we update our YouTube channel with new videos. So PVAMU Research on YouTube and also on all social media. So without any further ado, let me introduce to you Dr. Anil Kumar.
You can see on my screen, right, you all?
Yes, we can.
Okay, great. Well, good afternoon. Appreciate you joining us, and I'd like to share the ideas with you. This is in my last presentation about a month ago, I talked some in generalities about innovation ecosystems. And today I plan to make them somewhat more practical, so we all know how ecosystems kind of work. And in particular, with the limited time, I'm going to give you a couple of examples where excellent innovations did not pan out because they did not have ecosystems as a part of the innovation. So, okay, okay. So case studies and lessons learned. So today what I'm going to do is I want to talk about the innovation ecosystems in more practical terms. And then I'll give you some specific examples of such systems. In particular, I'll discuss examples where outstanding innovations did not pan out because they were not a part of an innovation ecosystem. And being a training session, I'm going to pose a challenge to get your feedback and a couple of examples. And I'll conclude with some ideas on how to set up such innovation ecosystems. Let's take an example. Let's this is a silly example, but illustrative. Let's put ourselves back in 1910. Ford Model T was just introduced. It was 20 horsepower, top speed 45 miles per hour. Okay, and at that time we had very few highways. We hardly had any interstate highways. For fuel stations for few and far in between. And let's say we tried to introduce innovation in 1910 at the first Ferrari, which actually came out in 1947. But imagine somebody came with an innovation in 1910 with a Ferrari, okay? It takes 0 to 62 in mph in 3 seconds, but 500 to 800 horsepower, top speed 205 miles per hour. The question is, could this innovation have sustained in that environment? Okay, so I'd like to see at least a couple of responses from you guys on whether this innovation would have sustained with the environment I just described. No responses? Well, I'm going to answer my own question. So basically,
responses. One says no.
Oh, okay. Why? I want to know why it doesn't. They can speak. I don't go to the chat. They can talk. They can.
Dr. Sula, if you'll unmute and answer the question, why wouldn't it be sustained?
He said there were very few highways, and with the speed of the Ferrari, there would be the highways whatever highways there were would not be conducive for such a horsepower.
Yeah.
And there's another answer. No, because there's no infrastructure.
Right, exactly. That infrastructure is exactly what we call an ecosystem here. Okay. So in order to get this Ferrari in 2010, we need to have highways. We didn't have them till about 1950 actually. Okay. I don't know what's going on, why it doesn't respond. Every time somebody comes up, okay. Well, look, we didn't have equipped garages with trained mechanics. I think every time somebody logs in, Karen, what's happening is I lose control of my screen. Anyway, we didn't have frequent gas stations. In fact, the first service station didn't come till 1913. We didn't have a supply chain for parts, no delivery mechanisms. Just a few examples of lack of infrastructure. So this sets a scene for what I'm going to talk about in a few minutes. Namely, having a great idea and great innovation is not enough. It's got to have a lot of coexisting parts that has to go in to make the innovation possible. Okay. So the point I'm making is, for innovation to be successful, it has to add, if you remember, I mentioned this in my last presentation, it has to add, it has to address a specific need or real challenge. It has to add value to the company, add value to the customer, and have the potential for adding new customers and new territories, scalability, and most importantly, should have a support system. We didn't have that for this kind of a thing. You could say this is a bit of a far-fetched example. I mean, nobody thought of a Ferrari back in 1910, but as I'm going to show you a couple of examples which happened in our own lifetime in the past 20 to 30 years, which flunked out, not because they're not brilliant, because they just didn't have an ecosystem. Okay, so one example is the field of a transistor. I won't discuss this too detailed, technically detailed. Okay, but Michelin, for example, in 1992, instituted an idea called a PAX tire. I'll talk about it in a minute. Okay, but in 98, they introduced it. It's a brilliant innovation, but it failed in a few years, and we'll see why. Another example is Philips, for example, pioneered high definition TVs back in 1980, mid 80s. Excellent screens and stuff like that. But again, it flunked out because it didn't have a support system that had needed technology to support this. So in each of these cases, the innovation was a failure because it wasn't a part of an ecosystem. Now, before I go on, I want to, this being a training session, let me pose a challenge to you, more futuristic challenge, and ask you for your input. I'm sure you all heard of Uber Air, right? Uber Air is building a future of aerial ride sharing, not the taxi that we have right now. In 2023, Uber plans to give the riders an option of affordable shared flight, carry up to 4 passengers on trips up to 60 miles and speeds up reaching 180 miles per hour. And they'll be flying about 1,000 or 2,000 feet above the ground, okay? And a lot of partners are involved in that. This is not like one company doing that, okay? Vehicle designers, manufacturers, policymakers, regulators, all kinds of stuff, okay? So this is what typically it's going to look like. These are they call electric, vertical, and takeoff and landing systems. Okay, so the challenge is for you to think about. I would give you a couple of minutes and ask the following question: for this taxi to be realistic in 2023, do you think we have the right ecosystem to keep it thriving? okay? And next question is, what components of the ecosystem would you need to sustain this innovation? I'd like to hear from a couple of people. And we had a discussion of Ferrari, for example, okay? In the same way, now we are looking futuristically. If we are going to be part of this, what do you like to see? Or what do you need, what kind of ecosystem do we need to get this a reality? Anybody thinking? I just went to sleep or?
We're typing in the chat. Do you want us to unmute?
Yeah, I think talking is better. That way everybody can hear in real time.
Yeah, so a couple of things I just thought of, and I'll turn it over to other folks. One, pilots, right? You'll need people who are trained to actually fly these things.
Absolutely.
Another thing is that, I mean, we already have issues with our air traffic control right now.
Right.
So just imagine what our air traffic control is going to look like when we have hundreds of these things in the air.
That's right.
So those are two things that came to mind immediately.
And of course, the aircraft control definitely is an issue, but these things will be flying like 1,000 or 2,000 feet. So it's not the same kind of a problem, you know, for several thousand in the air.
Exactly.
Someone else said we need a clean burning fuel source.
These are electric.
These are electric.
Okay, so they're fully electric?
They're supposed to be, that's what they're planning on. That's what they call it eVTOL, namely electric vertical takeoff and landing systems.
Okay, so they require charging stations then, much like we see for electric cars. So they will have to build the charging stations for them at specific locations. So that's a consideration in and of itself.
That's right.
And it would be at a price point that would make it accessible.
That's right. What else do we need to keep this thriving and be realistic?
They would definitely have to be in a post-COVID society.
Definitely.
Let's hope 2023 is a post-COVID society.
Let's hope.
And I know we don't have to worry about the air traffic control system that we would use with an airplane, but I do think we would need some system of air traffic control, especially if you've got multiple companies doing the same thing. And it would be best if it was a platform that they all could share.
That's right. I agree.
I see the locations listed where I think the Dallas-Fort Worth area and LA. I heard about a place like Chicago. Like, how would this be implemented in Chicago? More taller buildings, and also it's known as the Windy City for a reason. So how well
That's right.
the helicopters work in windier city?
Yeah, the turbulence is going to be a problem. Absolutely. Yeah. And of course, Australia is getting onto the game. So anyway, let's kind of go on. So obviously we need skyports, you know, where they have to kind of land and take off, for example. That's going to cause a lot of real estate stuff. Battery technology is very important because aircraft use up more power than electric cars, for example. Okay, and charging stations, as Sheena said, that they are more frequent. Okay, parking for cars, scooters, and bicycles, for example. Noise pollution mitigation is a very important thing because the range is only about 1,000 to 2,000 feet. And then the cost, initially, it's going to be about $5 to $6 per passenger mile, is supposed to get down to 44 cents eventually, depending upon the volume and so on. And helicopters right now is about $9 per mile, okay? But even $6 per passenger mile is a little too much. Pilots, as Leland said, the numbers and the training is very, very important. And obviously we need a lot more of them than for regular airplanes, for example. And then more importantly, integration with the existing transportation systems. Because one of the things that we are interested in is we may not want to fly from every place to every place. Those segments of the cities where we have traffic congestion, that's what we want to avoid. For example, the recent Google study showed that the average speed on these highways, like in San Francisco, Los Angeles, and so on, in 1970s were about 40 miles per hour. These days, it's about 20 miles per hour. So that congestion is what is causing the problem. So integration with the existing transportation system, and I'm sure few others that we haven't thought of, I'm going to. So again, that's a part of the ecosystem for the Uber Air. Okay. These are a couple of videos. I don't show them completely because they take time, but I'll send you the links if you're interested. Let me show you the first 30 seconds. Okay. This is the Hyundai Taxi. This was shown at the Consumer Electronics Show.
Throw the word mobility around like crazy, especially at CES. But this year, Hyundai, you know what? We're going to go one step further and create our own air taxi. The SA1 is Hyundai's air taxi that'll transport 4 passengers. Now, initially, it'll have a pilot, but the plan is to make it autonomous because, of course, in the future, everything will be autonomous. Uber and Hyundai have partnered together for this vehicle. This is actually the first partner that Uber's had that has the manufacturing prowess of Hyundai. And in the future, we'll be able to get in this air taxi and get away from all the traffic and apparently all the regular people who are trapped on the earth. The SA1 will have a cruising speed of about 180 miles an hour. And it'll fly within elevations about 1,000 to 2,000 feet. And it'll have a range of 60 miles. You're not going to fly this from, say, LA to San Francisco, but you might use it to go from maybe San Francisco to Palo Alto or to Oakland or LA to Malibu. And of course, that partnership with Uber means you'll be able to book one of these things through the app. Now, when you have a lot of these in the sky, which is what Uber and Hyundai and a bunch of other companies want, they're going to come up with some safety issues. Hyundai says that because of all the propellers, if one fails, the other ones will pick it up. There's a lot of redundancies built into this air taxi. Plus, it'll have a parachute. So if everything fails on this EV, it's electric, then it'll just float to the ground, hopefully not on your house. Now, the way this thing works is it's not like your typical drone where all the propellers are always pointed down. It's a bit like a Harrier. Those back 2 propellers, when you take off, they are pointed down. But once you get going, they turn. And when those turn, it propels the SA1 forward. Now, Hyundai and Uber have thought beyond just the flying machine. They are talking about a hub. There's the S-Hub where these things will take off and land. And to get to those, they have these little autonomous pods. Hyundai, during its press conference, said that they would like these little pods to be as iconic as San Francisco's cable cars. I don't know about that. I don't know how much regional flair you can add to, well, a tiny metal, it looks like a pill. But it will create this sort of hub and spoke situation.
So you see, the technology that went in there is very, very fascinating. And flight dynamics are very different from a regular plane or a helicopter. We won't go into that today. Maybe I'll talk the technology some other time. For example, these air taxis would have, for example, they don't have turbines or motors, for example, rotors like helicopters do, for example. So, and the way they get the lift is different from the way the helicopters get the lift, for example, okay? So a lot of technological advancements are extremely exciting. But anyway, the point was here for me to introduce to you something coming up, and let's start thinking about how maybe even we can contribute towards the ecosystem for this for the next 2 or 3 years. Now what I'd like to do is to talk about a couple of examples of innovation that did not achieve their potential owing to the lack of an ecosystem. One is Michelin. Michelin's called PAX tire. So typically, that's just a picture of the tires inside. In '98, Michelin launched a PAX system which would allow drivers with a punctured tire to continue for 125 miles up to 55 miles per hour before having to change it. Before having to change it. So the run flat tire would eliminate the danger of blowouts, the frustration of roadside tire change, and inconvenience of waiting and so on for people. Okay, and industry analyst J.D. Power and Associates, they forecast that by more than 80% of cars would be fitted with run flat tires by 2010. Of course, we don't see any of them. Okay, and that's exactly what I want to talk about. Okay, so as of the tire itself, this is the part of the ecosystem we are going to be talking about. Okay, in addition to the tire technology itself from Michelin, it needed a lot of other things. For example, a revolutionary wheel hub that would clamp the tire rather than rely on a tire pressure, for example, okay? An inner support ring that would sit between the tire and the wheel. A pressure monitoring system, so you have a warning on your dashboard that something went wrong. Also, because the pack system was integrated into the car, it needed to be incorporated into the vehicles at the design stage. Finally, the repair process would require garages to install dedicated new equipment to unclamp and reclamp the tire and the wheel. So as you can see, any of us who went to discount tire service, for example, to have our tires changed, you can see how much of a new stuff these things needed. And this is the ecosystem that we are talking about, okay? So, and Michelin was aware of these challenges at the outset, okay? So they're trying to get the partners on board, okay? And of course, automakers saw an opportunity, for example, but then the garages would get higher margins, okay? And then now they also licensed the industry, to like idea to technology, okay? And so, but what happened? Despite the enthusiasm, the car makers, garages, they had a problem. For drivers, it meant the tires could not be repaired, only replaced, which was far more costly proposition. And these tires were not cheap. In the US, several class action lawsuits were filed accusing Michelin and others of failure to disclose the paucity of repair facilities. Okay, people thought they could have the tires repaired. They couldn't do that. Finally, in 2007, Michelin ended the further development of packs. As you can see, so what happened was no repair facilities, okay? Mechanics were not trained, okay? So Michelin said it sold more than 200,000 pack system assemblies, okay? So now, what is the reason? The sort of failure of the packs, this slide is important. The failure of the tire was not caused by a misunderstanding of customer needs or inadequate technology or losing out to competitors. Okay, this is what we already come up with an idea, okay? The failure was caused by misunderstanding of the ecosystem, namely the garage buy-in, for example, okay? The garage incentives to install the special repair equipment depended upon number of cars with that. So as you can see, for garages to make money, they need a lot of cars. But for them to buy the new equipment, they needed to compensate with the expenses they had to put in by the volume of the cars coming in. They didn't have that. That's a part of the ecosystem, okay? So even the packs became standard on new cars, but many years before they would account for meaningful percentage of repairs, okay? And any company making the transition from standalone products to integrated solution, is signing on a reconfiguration of the sort. This is the point I want to make. So getting innovation is not enough. New links and new actors and new roles are needed. So success requires an assessment of interdependence among all partners and clear strategies to manage them. It's no longer enough to manage your own innovation. Now you must manage your innovation ecosystem. As I'm going to show you in a slide little later on, in the olden days, when I say olden days, 25 to 30 years ago, most innovation came from big companies, General Motors, Ford Motor Company, Intel, stuff like that, where the big company handled everything needed. The supply chain, the parts, for example, everything. But today's technology, like I talked about in the last presentation, the iPhone is a good example, for instance. This is a platform economy where a single company cannot handle everything. They needed a lot of co-inventors, to come in to support the innovation. But Michelin didn't have that at that time. The second example I want to discuss with you is the high definition televisions that we have now. But back in the 1980s, they didn't have that. But Philips, Sony, and Thomson, they invested billions of dollars to develop TV sets with astonishingly high picture quality, okay? The company's executives drove the development effort, to creating numerous breakthrough television technology. And the picture quality was outstanding, something that we would love to have had even at that time, for example, okay? If you remember back in the 70s, and we used to have, for example, those of you who are very young, you don't know this, but we used to have this big consoles, stereo systems integrated with TVs, and stuff like that. So people would have loved to have this incredible picture tubes, but it didn't work. It didn't work because the technology wasn't there to support that. Philips had this stuff, but what was missing? The critical components weren't there. For example, high definition cameras weren't around at that time to actually produce the product that is going to be shown on those TVs. It's one thing to have a fantastic screen, but if nobody has a high-tech camera to produce like a TV show or a movie or something like that can be shown, it doesn't make any sense. There is no medium. I mean, the medium is there, but the product is not there. The technology, the signal compression technologies were not fully developed, okay? And and the broadcasting standards were not set up at that time for a high definition TV, okay? So this basically was the ecosystem that was lacking for Philips, and they were left with a $2.5 billion write down because they had incredible innovation, but the ecosystem was just not ready, okay? So these are two examples I want to talk to you about. So I hope by now, you know what I mean by the innovation ecosystem that has to go in parallel with the innovation. Other examples, some of you might know back in 2003, Sony came up with their e-reader, for example. It didn't catch on. You can guess why. Because they didn't have access to the e-books, okay? And the Kindle came in 2007. And I'm sorry, there should be Nook, not Noon. I'm sorry about that. Typo on my part. The Barnes & Noble Nook came out 2009 and iPad in 2010. And the reason why these are thriving, because they had a complete ecosystem in terms of the millions of books available, which the Sony missed out on that. Johnson Controls similarly had they had some incredible electronic switches and sensors, but they didn't create a market from the architects and the electricians and so on. Okay, so the question is, what do I want you to, any questions so far you have before I go on? Well, interrupt me anytime you feel like, okay? So what do I want you to take away from this session? This is what, there is an interesting book which I'd like to share with you. I mean, the link by Ron Adner from Dartmouth College. He wrote a book called Wide Angle Lens. What he pointed out was having an innovation is not enough, okay? If you see this picture here, at the center, you see the execution focus, which is what innovators normally focus on, the right innovation, the technology and stuff like that. But in order to make the innovation successful, we need a wide angle lens. On the one side, you need the adoption chain. How many people are going to adopt the technology so you can make your innovation worthwhile? On the other side, the co-innovation, namely what are the supporting stuff you need to make your innovation a reality. So basically the bottom line is innovation does not happen in a vacuum. It requires connections, and those connections come from innovation ecosystems. I want to make it a bit more clear in the next slide. So individual product and services, innovation seldom add any value in isolation. Innovation in isolation doesn't make any sense. They have to be integrated and physically bundled, okay? And that's a potential risk, okay? Because a particular innovation can appear to create competitive value by itself, but by itself, it's not useful. For example, Intel might come up with a computer microprocessor, for instance, which is extraordinarily fast, for example, but it can't go anywhere because most other components in your PC or whatever cannot keep up with that speed, okay? It's kind of like putting a Ferrari engine in a dump truck, okay? It doesn't work. So a huge range of internal and external factors are needed, okay? And so innovation can have interesting and positive characteristics in and out of themselves, okay? But in a real competitive situation, there are hundreds, if not thousands of internal and external factors, and those things have got to be addressed immediately. This is an evolution of innovation I want to share with you. As I said before, 25, 30 years ago, most innovation was pretty closed because most big industries, the Boeings and the General Motors, most innovation took place within the big, huge industry, and everything was closed, okay? Everything has happened inside. But then over the last 25, 20, 25 years, but the top products that came out that needed other things to support them. So the open innovation requires either collaborative innovation or an ecosystem innovation, okay? So I'll share this slide with you. So basically, the industry has changed from like a linear kind of a development to what we call a platform industry, where no one person industry owns everything, but lots of pieces come together to make a product possible. Like in my last month's presentation, I talked to you about a Sony electric car, for example. Sony doesn't know anything about electric cars, but they formed an ecosystem to produce an electric car. Okay, so now this is the kind of stuff that we need to establish at PV. Okay, we have at the microscopic level, we have the knowledge ecosystem. We have that already. We have a lot of researchers, for example, a lot of ideas, for instance. And the next generation we need to build on is the innovation ecosystem. Okay, namely for any innovation we want to come up with, what kind of supporting stuff that we need. And then eventually the business ecosystem, where we are going to be able to produce them into products, prototypes and products and so on, and then to eventually to the market. In my last presentation, I showed you this picture which I made. At the bottom level, we had a knowledge ecosystem, if you remember, and then we had the innovation ecosystem and a business ecosystem. The knowledge ecosystem is what we have already at PV. We have these research centers, for example, a lot of stuff being done, okay? So that's where the ideas and innovations come from. But we need to build an innovation ecosystem so that those innovations can begin to see what they need to do to get them to the real life. Now, I'd like you guys to see this. I came across it a couple of months ago. It really blew my mind. It's called, look at the title, misappliedsciences.com. Very catchy title. But what's interesting about this is they claim they came up with a display which makes the display personal to the viewer. Okay, remember the movie Minority Report that came like 20 years ago or 15 years ago with Tom Cruise, where the billboards, they were marketing to the individual as they're passing by the billboard. So this one seems to be like that. So basically imagine, and I think I have another picture here. Okay, no. Imagine, yeah, let's see, do you have another one? No, I don't. So imagine a display in an airplane, for example. Okay, a display like this one. Okay, so each person looking at it, he's going to see his or her own display. Okay. How do they manage it? I really haven't figured that out yet. Okay, but it's very fascinating. And it's realistic enough for United Airlines right now, the $44 billion company is actually marketing, licensing these people to provide a unique traveling experience, in their flights, okay? So when you get a chance, take a look at their website. It's extremely fascinating, And basically their claim is a new technology. On the left side, you see a conventional display with the pixels, okay? Outputs only a single color at any moment. Whereas the right side, as you can see, is a parallel reality displays. They give you multiple colors and so on. Apparently, that difference in the technology makes the display unique to the viewer. It's incredible, okay? And again, as I said, I haven't learned enough about this to see how it's working, but this is somewhat futuristic. So in closing, we already have a good knowledge ecosystem of PV, state-of-the-art research centers, individual research projects, and accumulated knowledge from the prior efforts. We are now in the process of building an innovation ecosystem to provide guidance and assistance to innovations generated at PV or from among our collaborators. And an innovation ecosystem is not static. That's what we need to understand. It is not like a group of people, for example, like a committee or something like that, on call so that we can go to for advice here. The innovation ecosystem is not static, as you saw already. Depending upon the innovation, it requires the support system needs to be different, okay? But hopefully we have generated enough expertise at PV as well as among our collaborators. So depending upon innovation, we can pick and choose the people we need to make the innovation possible. So that's my story. I'm sticking to it. Any questions?
One question. So at Prairie View, there are a number of people who have developed things that are that could go to the marketplace. However, for those who know about the systems in place, they are able to move through the progress with technology transfer and so on. But those who are not aware of the process of how to move through technology transfer and getting their product to the market, what would be your advice?
I'm sorry, what's the last question?
What would be your advice to them on how to get connected?
Okay, first of all, I don't know if we excuse me, I have a dry throat. I don't know if we are set up in order to give advice to everybody in a way, but what we can do, I think we have enough expertise among ourselves to guide people to the process. Okay, but that depends upon at what stage the innovation is, for example. Okay, so depending, for example, have they done a market search already, for example? Okay, and if an idea is not a product. Okay, an idea is not a product. So we need to kind of, what we should do, we have a small group of people right now, namely the 4 directors of innovation, plus we have the experts who are the directors of research centers. So I think we need to start from there. So depending upon the innovation, we can get a group of people to have like a Shark Tank kind of experience, for example, for the innovator to make put in a pitch to see, and depending upon that, we can advise them where they need to go and what they need to do. That would be my starting point. The starting point would be like a Shark Tank kind of a pitch. Okay, I know that, for example, the College of Business used to have limousine pitches. Okay, I think Rick can probably talk about that. The limousine pitch is it takes about half an hour to tour the campus. So idea is during that half an hour, if we get to travel with a industry person, can you tell them your product? So the expert is, I mean, the boss is going to say, this is fantastic. That's my card. Call me.
I think that's a wonderful idea. And Dr. Lovelady did touch on understanding how to pitch your product properly when she did her presentation. And I think that's something that is valuable for all of our researchers and those who are interested in moving their product to market to know. So thank you for that.
And we can also provide training sessions, for potential innovators. Okay, once a month or whatever. But that's what I plan to do during the fall, for example. Starting the fall, once logistics are set as to how we are going to be working in the fall, face to face, stuff like that. But those training sessions can give them a beginner's idea as to, okay, what do I need to do and everything. So
absolutely. Here's another question. First, the question is, do we have an incubator on campus? That is the question. But before you answer that, I'd like for you to explain for the audience, what is an incubator?
Okay, an incubator, basically, the ideas came up about maybe a couple of decades ago. And they mushroomed quite a lot. In fact, I worked on incubators at HBCUs about 15 years ago. An incubator basically is something exactly what the name says, namely it incubates the idea if you have an idea. But of course, incubators come in all kinds of shapes and sizes. We can have technology incubators. We can have business incubators, for example. Okay. But the basic idea of incubator is we provide space, for example. Let's say we can have, for example, the ICE building that we are supposed to be building, for example. I can envisage larger number of rooms out there, which are going to provide space at a very reasonable rent to somebody who wants to develop their product. Okay, I'll give you an example. Let's say I'm an outsider. I don't know anything. I have an idea. Okay, so I write to you guys, and then so you give me the space, and also maybe the technical expertise, because you have the technical expertise and I don't, for example. So you give me an office space, maybe even a secretarial staff and things like that. So that way, for 6 months or a year, you allow me to incubate my idea. it could be like a software program or a prototype. I can give some examples of incubators in my next presentation. So that's what incubator does. It gives you a time. Some incubators do 6 months. Some do up to 1 to 2 years, for example. Okay, it depends on how long it takes. Okay.
So an incubator is an opportunity and a space, and it provides support in a variety of ways for you to develop this idea that's been rolling around in your head, to actually have a space that you can call your own to grow your product into something that is marketable.
And also for the product to be tested, for example, we have the labs on the campus, for example. As an outsider, I might not have access to test my own labs for my own product. But at the universities, since I'm collaborating with you, for example, as an outsider, you would give me that space and expertise. But perhaps we can have a co-licensing, for example, for instance, or I could just pay you for the testing, for example. So the incubator has a lot of facilities and expertise available, which the individual person normally does not have available. And also, the other concept is accelerator. The accelerator is basically the next generator of facilities which can take your product from a concept into a prototype, for example, and we can also provide assistance in developing proposals to SBIR and STTR kind of proposals. Those are small business innovation research and small business technology transfer programs, where the government would give you typically up to, for the first phase one typically is about 6 months to a year. Depending upon the agency, that can give you anything from about $50,000 to $100,000 a year just for proof of concept. And a phase two, it can give you anything up to $500,000 to $1 million to develop your idea into a prototype. The phase three, normally, the government doesn't give you the money for that. You have to license it with the industry, for example, to see how to get the prototype into a realistic product that can be marketable. But the advantage of SBIR, STTR is this is not a loan. This is a grant, okay? So you don't have to pay the money back to anybody, okay? But that's where that we can come in as universities to provide assistance.
So since you mentioned the SBIR, and how would a person access that?
But that's open to everybody. All they have to do is to go to government agencies to do that. But since we have Office of Research and Innovation on our campus, and we have, like Krish, for example, sends out those notices very periodically. So so somebody can go to him and say, hey, I have this idea, can you help me identify an agency that would fund my idea, okay? And we can provide the training sessions on how. In fact, I used to do that for 10 years. I actually ran a small business development program where I used to tutor, small businesses on how to write the proposals for SBIR, STTR. Okay.
I'd like to remind everyone to please complete the brief survey that is in the chat box. And I want to go back to the question about the incubator. Do we have an incubator on campus?
Not to my knowledge. We had a lot of discussions for the last 20 years or so, but really don't have an incubator, on the campus. We could start having one basically what it requires is a physical space, with some facilities like a photocopy machine, secretarial support and things like that. So, and I don't think we really have any space left on the campus. We could probably generate one in our Northwest campus, for example, which is more accessible to industry. But ICE, when it becomes a reality, that probably would have, incubator, but I don't think we have one on the campus.
Okay, thank you. Thank you for being clear on that answer. I know that there is some space being developed for innovation, commercialization, entrepreneurship, and economic development. And perhaps in that space, maybe there will be room for an incubator or something similar to that. So if there are no other questions, This is your last opportunity for questions. So if you have a question, please go ahead and put it in the box. Please remember to complete the brief survey. I want to thank you, Dr. Kumar, for sharing this wonderful information with us. And we want to make sure that there's an opportunity for our researchers to grow and move their products from the lab or the field into the marketplace. So we want to thank you for sharing this information today. Also, I want to remind everyone that on Wednesday of this week at 3 p.m., we'll have another research data blitz. And it's a wonderful opportunity for you to get to know the research that is happening on campus. So many of us are busy doing our things, so we don't know what the researcher next door is doing. So this is an opportunity for you to find out about the research that's happening right here on the campus of Prairie View. And that'll be on July 22nd, this Wednesday at 3 p.m. And we'll see you back here again next Monday for another great RITI session. Thank you. Please complete the survey and go to our YouTube channel at PVAMU Research to see the video. Thank you. Have a great day.
You too.